Jack Jackson. In this video, we're going to talk a little bit more about box plots. We introduced those in the last video, but we're going to talk about it a little bit more here. Before we do that, let's review a little bit about quartiles. Quartiles are used to divide the data into 4 equal parts. Okay, it takes 5 numbers actually to do that, and I call all 5 of those numbers quartiles. Some authors only call what we call Q1 and Q3, the lower and upper quartiles, as the quartiles, but actually all 5 of them are needed to break the numbers up into 4 even pieces. So of course Q0 is the minimum, the lowest one. Q4 is the maximum, the highest one. And then the median will be the Q2, which breaks this data into half below and half above. And then Q3 and Q1 are the quartiles. Now there are different ways of doing the Q1 and Q3, but if we use, for example, the TI-84 method, then Q1 is the median of the lower half of the data, and we do not count the median as part of the lower half. So if we rank the data in order from lowest to highest, we find the median by taking the one that's in the middle of that list so that there's the same amount below it or above it. Now remember, if the median, if it's an odd number then of data in the sample or in the population, then the median is going to be one of the data values, and there are n-1 over 2 data values below it, and n-1 over 2 above it. If we're finding the first quartile, then we take those n-1 over 2 data values below the median, and that's going to be called the lower half, and then find the median of the lower half. Now remember, if n is even, we find the median by taking the 2 that are tied for the middle. The 1 would be in the n+1 over 2. N+1 over 2 is going to give you a number between 2 whole numbers, and take the 2 positions either side of that, and that tells you the 2 numbers you average to find the median. Okay, and so there will be exactly half the data below and above that median value. The numbers that are below will be the lower half. Take the median of that lower half, and that's the Q1. Similarly, we take the upper half of the data, where the median's not counted as part of the upper half, and find the median of that to be the median. The Tukey method is very similar to that. It works just the same way, except, in fact, it's exactly the same way if n is even. But if n is odd, then the Tukey method counts the median as part of both the lower half of the data, and it counts it as part of the upper half of the data, and then you go on to find the median of those 2 halves. And there are other methods of finding these, but those are 2 of the most common ways. The point is you get these 5 numbers, called the 5-number summary, or the quartiles, and they divide the numbers into fourths, the data into fourths. And what a box plot, or sometimes called a box and whiskers plot, it gives you a nice visual representation of the quartiles. So for example, let's assume on this particular example the quartiles have a minimum of 20, that's Q0. Q1, the first quartile or lower quartile, is 25. The median, or Q2, is 27. Q3 is the upper quartile of 34, or third quartile. And then the maximum, or Q4, is 60. So those are your 5, that's your 5-number summary, or your 5 quartiles. And then what you do is you take a number line so that the number line is evenly spaced out, and you just draw a little vertical line. The way I do it here is make them all the same length, vertical line, at each of these 5 numbers. One at 20, one at 25, one at 27, one at 34, and one at 60. That's at the minimum, Q1, the median, Q3, and the maximum. And then you draw a little box by closing off the top around this middle half of the data from Q1 up to Q3, and that's called the box. And then the whiskers go from the center of that box all the way out to the center of this vertical line out here at the maximum, the upper whisker, and the lower whisker goes from the center of the box right here, the center of this edge of the box here, down to here at the minimum. So the bottom whisker, or lower whisker, goes from the minimum to the first quartile, and the upper whisker goes from the third quartile to the maximum. And so what this does is you can visually see that 1/4 of the data is in here, in this lower whisker. 1/4 of the data is in this lower part of the box. 1/4 of the data is in the upper part of the box. And 1/4 of the data is in this upper whisker. The box makes the middle half. So half the data is from this median down. Half the data is from this median up. 1/4 in each of these 4 spots. And then 1/2, the middle half, is in the box. So that's a box and whiskers plot. Now, oftentimes you'll see a box and whiskers plot modified to indicate outliers. Okay, so we'll talk a little bit more in a later video about what outliers are, and I'll come back and show you a modified box plot where the box plot takes into account outliers. So if you don't care about outliers, this is just a basic box plot or basic box and whiskers plot. So let's see if you can do this yourself. Okay, try this exercise here. We're going to use the TI-84 definitions for Q1 and Q3 for this particular exercise. And here's a data set. 10, 15, 14, 14, 11, 17, so forth. Take this data set and see if you can make a dot plot for it. A box plot, excuse me. So make a box plot, and when you get it all finished and you got your box plot, come back to the video and check your answers. Press pause now. Well, the first thing we have to do is we need to take this stuff and put it in order. We're going to do this completely, let's say, by hand. And so here's the same data set reordered from lowest to highest, increasing order. And so if we count, well, first of all, the minimum then is easy to see is 9, and the maximum is 33. Now let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points. 17 plus 1 is 18 divided by 2 is 9, so the 9th one from the bottom should also be the 9th one from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the 16 from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the 9th one from the top. So 16 is the same distance from the top and the bottom in terms of this ranked list. Okay, so that they're the same number of data points above and below. Almost half, right? Half if you don't count the 16. Half is below and half is above. So that 16 is the median. Now, if we're going to use the TI-84 method, then this is the lower half right here. We don't count the 16. Of course, with the other parts in the upper half. So we just look at those numbers right there, which I've recopied here. So now let's see, that's 3, 6, 7. There's 8 there. Well, if you do 8 plus 1 divided by 2, that's 9 divided by 2, that's 4.5. So 1, 2, 3, 4.5 would be halfway between the 4th and the 5th one, halfway between the 13 and 14. Or another way to think of it is the 13 is 4 from the bottom, the 14 is 4 from the top of this lower half. Here and here. So it's tied. So when we have a tie, we just go halfway in between the two. To get halfway in between the two, you add them up and divide by 2, which is 13.5. So that's going to be the Q1. If you have the, so then you similarly do the top half, and if you use the TI-84 method, the top half does not include the 16. So we take those points there, those data values there, which I have right here is the upper half, and again, we're going to have a tie for the middle, so we have to average those two to get 19.5 for the upper quartile. So the 5-point summary now is 9, 13.5, 16, 19.5, and 33. So there's your 5-number summary. That is Q0, Q1, Q2, Q3, Q4, or more often said, minimum, Q1, median, Q3, and maximum. And so I've got that sort of notated here. Here's the minimum. In between, here's the 13.5 is the median, is the Q1. 16 is the median. Right here at 19.5, where this vertical line is Q3, and the maximum's up here. And so we have, at least approximately, we have 1/4 of the data here, 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 and here. Now, how does this translate to a box plot? Get to number line. The number line's got to go at least from 9 to 33. I went a little bit extra here. And draw vertical lines at all of these values. 9, 13, okay. Yeah, it looks like that one's off just slightly. Oh, 13 and a half. No, that's right. 13 and a half, so it's right on. 13 and a half, 16, 19 and a half right there, and then 33 here. So you have those vertical lines, and then just box in the middle half and draw your whiskers out to there. So a fourth of the data is here, fourth of the data lays in here, a fourth in here, and a fourth in here. Middle half is right here. Now, one of the ways, so box plot gives you some idea of where the data lies on the number line here, and it also gives you an idea of how it's spread out. So a lot of the data, a fourth of the data is kind of clumped in pretty closely together right here, and fairly close for this fourth. The top fourth is kind of spread out quite a bit. In fact, it might even have an outlier here when we later on talk about outliers. And then there's your bottom fourth there. One of the benefits of a box plot is when you have two classes, or two data sets. So let's suppose this is a box plots of test scores from, let's say, Mrs. Jones Algebra 1 class and Mrs. Adams Algebra 1 class. And this is their first unit test. And Mrs. Jones class is the red one on the top, and the blue one on the bottom is for Mrs. Adams class. Can you make any comments about the relative performances of the two classes? Press pause and think about that a minute. Okay, well, when you come back, we come back here, what can we say? Well, a couple things. We can say that overall, the blue one, Mrs. Adams' class, did a little better. How can you say that? Well, if you notice that 3/4 of her students were like 65 and up. Okay? So over 3/4 scored above 60, whereas only half of Mrs. Jones' class scored above 60. Okay, and then we also know that half of her students on Mrs. Adams' class scored 70 and above, where only half of Mrs. Jones' class only scored 60 and above. Now, the best scoring student was actually in Mrs. Jones' class, made a little bit higher. Let's see, what was it? A 91, 2, 3, 4, 5, 96, whereas the highest scoring student in Miss Adams' class was only a 95, but that's not much difference there. The lowest scoring student was definitely in Miss Adams' class, who scored 40, whereas the lowest scoring student in that's Mrs. Jones' class, excuse me. And Mrs. Adams' class, the lowest one was 50. So we see that on average, the Mrs. Jones class didn't do as well. And also there's a bigger range here. We went all the way from 40 up to 96 for Mrs. Jones class, whereas the scores are much more closely packed in here. And in fact, if you look at just the middle of the class, the middle 50% of the class, then we see that Mrs. Adams' class, that middle 50% is fairly tightly packed relative to Mrs. Jones anyway, from about 65 up to 83, I guess that is the middle half, whereas the middle half on Mrs. Jones' class is, not only is it lower in general, it's much more spread out from 50 up to 78. So we can see that Mrs. Jones' class is both more variable and has a lower, basically a lower center as well. Okay, let's stop there for this particular